Hi, my name is Anthony Coker, and I'm coming to you today to talk to you about the refrigerant recovery process. There's two methods of recovering refrigerant. One method is called the push-pull method, and the other method is called just a standard recovery. And the standard recovery, basically all that does is pull the vapor or liquid from a machine through the recovery machine and pumps it directly into the tank. That method is fine if you're doing refrigerators or small appliances under 10 pounds or something like that. That method usually works fairly well. But when you start getting into larger appliances or chillers or such, you're dealing with larger volumes of liquid, then in that you will want another method, which is called the push-pull method. Now what the push-pull method does is it pumps the vapor, it takes the vapor into the machine, pumps the vapor into the chiller, condenser, whatever it may be, and forces that liquid back to the recovery tank so that it speeds the process up. Once you move all the liquid, then you can switch back into recovery mode and pull out all the vapor. And I'm going to basically just walk you through this process that we have here. And what we have is basically, as far as components goes, is two 4-valve manifolds and two T's. That's basically all that we have here. I hooked the vacuum pump up to it, which you won't need it in the recovery process, but if everything's hooked up at one time, just showing you that you are capable of doing it, and only by doing it this hose configuration here, basically what it allows you to do is the push-pull and recovery both at one time, which means now you do not have to open the system up by switching the hoses and stuff and worrying with contaminants and issues in the configuration. So let's start off with this basically. So first we're going to do push-pull, which means valves 3 and 4 are closed. So by doing so, now basically in push-pull, you're hooked up to your tank, and basically what it's doing, I like to start from the recovery machine, so we'll go all the way from here. At the recovery machine, because it's running, it pumps out high pressure vapor, which runs through the line. Now it can't go to valve 1 because it's closed, which pushes it to valve 6, and it comes down to this T. It can't go to valve 3 because it's closed, so it forces it into the suction side of the chiller or the condenser, whatever it may be, and forces that liquid out of the condenser and into the recovery tank. Now, as it's forcing the liquid into the recovery tank, the vapor on the high side is pressed back out and into this T. When this T, it can't go to valve 4 because it's closed, it pushes it over to valve 1. It can't go to 3, which forces it down to valve 2, which goes back into the recovery machine. Now what happens, this is a loop that will run and run and run until all the liquid's removed. Once the liquid's removed, the vapor is just in a continuous loop. Then you have to remove the vapor. At that point, then it's time to switch over to recovery mode. So what you do is you close the valve, the red valve on the recovery tank. You close valve 1 and valve 6, and then you open up everything else. So now you're ready for recovery mode. Now in recovery mode is pulling the vapor from the condenser here. It can't go to valve 6 because it's closed, which pushes it over to valve 3. Okay, valve 1's closed, which pulls it from valve 2 into the recovery machine. It pumps it out of the recovery machine up to valve 5. It can't go to 6, which puts it over to valve 4. Comes over to this T. It can't go to valve 1, which means it pulls it straight and pushes it straight into the recovery tank. Now we allow that process to run until you achieve a 20-inch mercury. Now, in doing so, because condensers, chillers, and stuff like that have oils in them and all, they all contain refrigerant that's still inside them, and it takes time for it to boil off, or it may have capillary tubes or something that has to expand. So what you do is you let the system sit for 15 minutes, allow it to expand to see if there's any left in the system, and then you run it again. When it holds a 20-inch mercury, then the system's ready to be opened. And basically that's it. Any questions?